Okay, this video is about 2.3 parallel lines. We're going to be taking a lot of the information that we learned in 2.1 and looking at it in terms of the converse. Now remember, the converse is where we switch things. So if I know something about the angles, then I'm hoping to be able to prove that two lines are parallel. So how do we prove that two lines are parallel? Go ahead and take a moment and write what you think about how to prove that these lines are parallel. Okay, so looking at this here, how do I know if these two lines are parallel or not? They look like they might be, but they also look like they might not be, okay? But if I know that angle 1 is congruent to angle 3, so if this guy is congruent to this guy, okay, then angle 1 and angle 3 are what kind of angles? So take a moment and think about those and go ahead and write it down. They are corresponding angles. So if you came up with corresponding, then that's great. You're right. So if angle 1 is congruent to angle 3, then angle 1 and angle 3 are corresponding angles, okay? Now, if corresponding angles, so if two corresponding, I'm just going to write C-O-R-R, angles are congruent, all right, then those two lines are parallel. All right, yesterday we talked about if two lines are parallel, then the two corresponding angles are congruent. Okay, so this is going to be backwards from the last lesson. All right, let's look at angles 2 and angles 4. All right, what kind of angles are those? You're right. These are alternate interior angles. So I know that those are alternate interior angles. So all of our theorems from yesterday hold true. So if two alternate interior angles are congruent, then we have two lines that are parallel. Okay. Now if we think about the same side interior, I'm going to write SS int. Okay. If they are supplementary, all right, now we can remember same side interior, same side exterior, lots of S's here, okay? Then the two lines are parallel. If they are not supplementary, do you think that they're going to be parallel? Probably not. Looking at the parallel to parallel theorem. Okay, so we're given that line L is parallel to line M, and line M is parallel to line N. Okay, so I want to know something about this, all right, and this helps me with something. So if I look at this transversal, and if I extend it, maybe, we'll move that back in a moment. Okay, if I extend it to cross all three of those lines, okay, then I notice something. So I know, let's move that over a little bit. I know that L and M are parallel, okay? So that tells me that this angle here and this angle here are corresponding angles and they have to be congruent. Now I also know that M and N are parallel, so this angle here and this angle here are corresponding angles, and so they're congruent. So that must mean that this angle up here at the top is congruent to the one in the middle and the one at the bottom, okay? So if those angles are all congruent, then, okay, line L is parallel to line N. This is called the transitivity of parallelism. And we've already talked about the transitive property, and this is still true here, right? So if we have L is parallel to M is parallel to N, then L has to be parallel to N, and this is all because of the transitive property. Okay. Last but not least, we have the perpendicular to perpendicular theorem. Okay, I'm given that line L is perpendicular to line M, and line M is perpendicular to line N. So go ahead and use the picture I've already drawn, pause the video, and figure out how you would draw line M is perpendicular to line N on this diagram. Okay, so if I were to draw, oops, let's delete that. Don't know how that happened. Okay, if I draw a line here, okay, this line here is going to be line N. And I know that it's perpendicular to line M, right? They form that right angle. All right, so I know that this line here is congruent to this line here because they're both 90 degrees. Okay, so this means then L is actually parallel to N here, okay? The transitivity doesn't hold. Since the corresponding angles are congruent, L has to be parallel to N because that's one of our theorems from earlier. So if two lines, so in this case we have line L and line N, are perpendicular, remember that upside down T, to the same line, then they are parallel to each other. All right, and that gives us that line L is perpendicular to line N.